Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone. Welcome back to the course Deep Learning with Keras. In this session, we are going to discuss detail on Keras Model API. Model selection is an important part of data analysis and deep learning. Our main focus is to choose a specific model for a deep learning problem. Let's start the session. We already know models are one of the major components of Keras architecture. We have in fact two choices, sequential and functional API. In both the cases, we use core and some specialized layers like convolution, pooling, recurrent to create the solution model for a specific problem. I'm going to start with sequential model. The core idea of sequential API is simply arranging the Keras layers in a so it is called sequential API. In a simple way, we can say that we can use sequential API in case of single input and single output deep models. In this specific option, data flows from one layer to another in a given order until the data finally reaches the output layers. This sequential API is not very flexible. It does not allow to create models that shares layers or have multiple input and outputs. A sequential model can be created by simply calling sequential API as specified in this step 1. Then we have added a dense layer of 8 neurons mentioning the input shape of 2, and in the final layer we have added another dense layer with 2 neurons. So we have 3 layers. First the input layer, then dense layer, and finally another dense layer as out. This flow diagram will tell the same thing. So we have 3 layers. First one is input layer, then dense layer, and finally another dense layer. The data will flow sequentially from input to output layer. Now let's go to Jupyter to work more on sequential model. In this Jupyter notebook, we are going to work with sequential model. First, we will import sequential from Keras model, then import dense and activation layers from Keras. To plot our models, we have to import plot_model module from Keras utils. Now we will define our model as sequential, just calling this sequential API. In the next line, we are going to add a dense layer with 8 nodes. As this is the first layer, we have to specify the input shape. In this case, the input dimension is 2, and we are using ReLU as activation function. Using this final line, we are going to add a dense layer with 2 neurons. Let's execute this and generate model summary. This model has 3 layers. The first one is default input layer, then 2 dense layers. In the first dense layer, the input dimension is 2 and output dimension is 8. We can calculate param using input, output and bias features. The param is showing 24. 16 is from weights, which we got multiplying input 2 with output 8. And 8 is from the biases. As we had 8 nodes, there will be also 8 biases. So in total, 16 plus 8 equals to 24. Now in the final output layer, the input is 8 and the output will be 2, as we have defined 2 nodes in this second dense layer. The total param will be 18. The total trainable parameter will be 42, 24 plus 18. Now let's generate the flow diagram. First layer is input layer with input and output dimension 2. Now in case of first dense layer, the input dimension is 2, and as the dense layer has 8 nodes, the output dimension will be 8. In case of final layer, the input dimension is 8 and output dimension is 2. Now we will work with a bit complex sequential model with convolution, pool, dense and flatten layers. First, we are going to import our required models, layers and modules from Keras. This model has an input layer consisting of images of size 28 by 28 with one channel, a convolution layer with 32 filters with kernel size 5 by 5, a second convolution layer with same 32 filters with kernel size 5 by 5. After that, a max pool layer with the pool size 2 by 2, a flatten layer, finally a dense output with 2 nodes. Now let's execute the model summary to know about the overall model. We already know that the input shape is 28 by 28 with one channel. The output shape of the first convolution layer is 24 by 24 times 32. This 32 is coming from the number of filters in first layer. We get this 24 subtracting the filter size 5 from the input dimension 28. So it will be 28 minus 5 and adding plus 1 with it. So it will be 28 minus 5 plus 1 equals to 24. Now this param, our kernel size is 5 by 5. So we have to multiply 5 into 5. Our input channel is 1. So we will use another 1 here plus 1 for bias. And finally we multiply this with output dimension, which is 32. The result will be 832. For the second convolution layer, the output will be 20, 20, 32. For the second convolution layer, the output shape will be 24 minus 5 plus 1, which means 20 by 20 by 32. This 32 is coming from the number of filters from the second convolution layer. In this case, the param will be 5 into 5 into 32 plus 1 and overall multiplied by 32, and the result will be 25,632. Now in max pool 2D layer, we are using a pool size of 2 by 2. So the output shape will be half of the input shape. The input was 20, 20, 32 and the output will be 10, 10, 32. Then this flatten layer will flatten the input. So the output will be 3200. We get this just multiplying all these 10, 10, 32. So it's 3200. In final dense layer, we have 2 nodes. So the output dimension is 2. The param will be 3200 into 2 plus 2 from the bias. So overall 6402. We can get the total trainable parameter just adding all the params. Now let's go to the flow diagram. It starts with the input layer, then 2 convolution layer, after that a max pool layer, a flatten layer, and finally a dense output layer. From input to output layer, they follow a strict sequential flow. Now we are returning to the presentation to continue with Functional API. Functional API is an alternative approach of creating more complex models. It especially allows to define multiple inputs or outputs model and also models that share layers. Its working principle a little bit different. First we have to specify an input layer and proceed with it. This is an example of Functional API. In this model, these 2 convolution layers are sharing the input layer. Again, after max pool 2D and flatten layers, they will be merged and continue as a single layer. Let's go to Jupyter to work with complete demo. We import all the required modules, models and layers from Keras. This model will help us to generate functional model, and this concatenate will merge inputs. This model starts with an input layer of 28 by 28 with a channel 1. Then we have 2 branches. Both of them contains convolution, max pooling and flatten layers. These convolution layers share the same input layer. This input underscore data part means conv1 is connected to input data, which is the input layer. In the same way, this conv1 is connected to pool1 and pool1 is connected to flat1, and this is also organized in the same way. So both conv1 and conv2 are sharing the same input underscore data. Now this concatenate layer, it will concatenate flattened layers from two different branches. Then we have defined two dense layers. First one contains 10 nodes and the final word contains only one node, and this will be treated as the output layer. In this section, we are going to generate our model. This model function will help us to define a functional model. We have to mention the input and output layers. Finally, we will plot our functional model. This model starts with an input layer. Both these convolution layers are using this input layer. For this convolution layer, the input shape is same and the output shape will be 24, 24, 32. This 32 is coming from the number of filter from this first convolution layer, and we can get this output subtracting this kernel size 5 from the input size, 28 minus 5 plus 1, so it will be 24. The next layer of first branch was max pooling 2D with the pool size 2 by 2. The shape of the output will be half of the input, so the output will be 12, 12, 32. And in flattened layer, this input will be flattened. In the output we will get 4608, just multiplying 12 into 12 into 32. Now in the second convolution layer, number of filter is 16 and kernel size is 7. So the output of this convolution layer will be 22, 22 and 16. We can get this output just subtracting this 7 from 28 plus 1. The next layer in that branch is max pooling 2D. The output will be half of the input, and this flattened layer will flatten the input shape, so it will be 1936. Now in this concatenate layer, it will merge these two flattened layers. So the output shape will be 6544. So it just added the inputs. In the next dense layer, we have 10 nodes. So the input will be the same shape of the output of concat layer, and the output will be the dimension of 10. And in the output layer, we have only one node. So the output dimension will be 1. So in this specific example, our convolution layers is using our input layer. So this is a classic example of a functional API. Now we are going to the presentation. In today's presentation, we have worked with the Keras Model API. We have started with the Sequential Model API, and finally we worked with the functional API. So that's all for today. See you in the next tutorial.